Sorry for the delay, but we're all ready to hear. We're just on the front page, so if you just start from the environmental DNA front page, and I'll just keep walking through.
Okay, perfect. Are you going to change the slides as I go?
Yeah. You just say
okay, so.
Okay, ready when you are, Steph.
Okay, perfect. Hi everyone, sorry I can't be there. Unfortunately, as Kim said, I came down quite ill and couldn't make the flight. So just bear with me today, I'm running a bit slow. So I wanted to talk to you about environmental DNA and how we can use this to potentially look at eel populations, their distributions, and potentially their management. Okay, so environmental DNA has really taken off over the last 5 years or so, and much of the reason for this is the fall in the sequencing costs. These more commonly than being trusted previously. Next slide. So I wanted to give an example. This is an example I know quite well because it's from the UK, but there are lots of other examples across the world. But this is a great crested newt, they're very impressive looking. But the great crested newt has to be surveyed for in the UK. Whenever we do any kind of building work or anything like that, there are regulations in place to say that we need to survey for that. And in 2013, eDNA was the first time that eDNA was approved as a monitoring technique by a governmental organisation. So National England are our governing body who enforce regulation around that kind of stuff. So eDNA was first approved in 2013 as that method. As I know to date, in the UK that's still the only approved method, but we have some methods that are on their way in terms of governing bodies as well. But the paper that was done just after this became approved actually demonstrated that environmental DNA could give a 99% detection efficiency when we compared that with other surveys, so routine surveys like bottle tracking and water surveys in the case of great companies. And so eDNA is really taking off in terms of how we can use it for science and how we can use it to reflect the policies that we're making. So what can environmental DNA actually tell us about organisms? Well, at the moment, environmental DNA can give us an estimate of presence and absence. So it can tell you whether an organism is there or not. That can also then give you inferences about the distribution and range of those organisms. So for example, if you weren't sure where eels were and you wanted to know if they were present in your rivers, and how far they extended up the tributaries, and it can give you that kind of information. We're now in the process of using it to insert habitat preferences of the European eel in some of the work that we're doing in the UK. So it can give you quite good information about habitat preferences potentially as well. Quantification is one of those things that everyone wants environmental DNA to do. And it's on its way there, but it's not quite there. So at the moment, the main focus is present absence, but there are groups that can have relative quantification. So thinking about if you've got a small, medium, or large population, but not necessarily thinking about numbers. That's one of the things that there's a lot of work being done on at the moment, is thinking about the relative populations and linking eDNA quantification with population abundance. But we're not quite there yet. Hopefully in the future we'll be able to think about sex and life stages and this kind of detail that we would potentially be able to get from environmental DNA as well. But at the moment, that's kind of an ongoing project, and at the moment we're focusing on presence and absence. Next slide. Right. So in terms of, I thought this figure is quite a nice simple graphic, but it demonstrates that environmental DNA really is most useful, where you have organisms that are very low. So whenever you've got rare species or an early invasive, eDNA is very good at giving you early detection or identifying individuals that know population members where other methods must find them. So that's really the strength of environmental DNA, is rare or elusive species. Next slide. Okay, so how does it work? So I mentioned already that the external DNA from water samples. So the first thing you do is go out and collect a water sample. This varies depending on the technique, the organism that you're looking for. With eels, you use a water sample of around about 1 litre, and 1 litre has given us pretty accurate results so far. So we go out and collect a sample of 1 litre of water from the surface of the water body that we're looking at. We then filter that sample down. We do this on site, so we have an in-field filtration rig set up, and I'll show you some images of later. And we filter that sample down, and then we fold the filter and put it in a preservative buffer, which means we can leave it at room temperature, and we leave it there until it gets back to the lab, and then we can extract the DNA. Next slide. So the second part of this process is to extract the DNA from your filter. So with environmental DNA, you're extracting the total DNA from your filter. So you're extracting all of the DNA that's present. So that's not only going to be the external DNA that we're interested in, but it's also going to be microbes and bacteria and that kind of stuff. But we extract all of the DNA from the sample, and then we go on to amplify what we're interested in. Next slide. So the third step is the PCR, which for those of you that aren't aware is polymerase chain reaction. And all this is an assay reaction where we amplify up the DNA that we're interested in. So remember, we have all of the DNA that was present in that sample for us. So that so you can cost effective. So you need a huge go out right there. You can just send 1 or 2 individuals out to collect some water samples, and it's fairly quick and easy to do. It's a fairly straightforward method to use. The main things to be aware of is to make sure that you are preventing any contamination that you might have in the sample, and I'll talk a bit more about that later. You can sample for environmental DNA at any time of the day. So some methods for certain organisms you need to go at night time or daytime. So you can sample at any time of day, and you can also sample from very hard to reach areas. So for example, a few weeks ago we were sampling from some lakes for the European eel, and they weren't able to set the flight nets because there was a lot of vegetation in the way. So we were able to get some environmental DNA samples, and so it was really beneficial in that scenario. We tend to have higher detection probabilities. The methods that have been published so far for environmental DNA that have been compared to traditional methods demonstrate that the detection probability is a bit higher with environmental DNA, and that's down to how sensitive the technique is. So this technique is really identifying very small fragments of DNA that are present in the environment. And that's what makes it so useful for invasive or rare species, so any invasives that I mentioned. But we're also using it to detect diseases that are present in water bodies as well. So for example, in the UK, we have a problem with the crayfish plague, and that's been generated as routine sampling with environmental DNA now. Also for those species where it's quite hard to identify down to the species level by looking at them, eDNA can give you increased resolution in terms of the taxonomic identity. Next slide. Okay, what are some of the limitations of each? So like any method, environmental DNA has limitations. The biggest one probably being potential contamination. There's a lot of work involved in trying to make sure that your samples are nice and clean and that you don't get any cross-contamination between sites or between samples that are in the lab. The main way in which we do this is by bleach washing all of the equipment that we use to sample. And so we do a bleach wash for 20 minutes with all of the equipment that's used between different sample sites. It also means things like your boots. If you're sampling between different locations, your boots can potentially carry DNA between sites. So again, it's thinking about cleaning those between sites as well, or using boots. I already mentioned the false negatives. So this is if you don't get amplification of your species, you can't assume that it's not. And that was pretty similar to a lot of other methods that you'll probably use as well. Sample storage, generally samples need to be kept frozen. However, we have a buffer now which we can use, and there are a couple of different options out there that you can store your sample in at room temperature now. And then when you get back to the lab, that's what you would and that's what allows about some quantification. So we, as I mentioned before, we still in terms of life stages and more detailed information, except the population structure, that's something that we can't do yet, so it's very much a present absence method at the moment. But as I mentioned, the probabilities of detection are much higher, but they will vary with the different organism that you use and also the different habitat type that you're working in. Next slide. Okay, so I just wanted to bring you up to speed with where we're at in terms of European eel work that we've been doing. So we now have an environmental DNA method up and running for the European eel. And we've generated some novel primers and probe, and these are for that PCR assay that I mentioned to amplify the eel eDNA up. And those target cytochrome B, which is mitochondrial DNA that we can hope to find in the environment. We've been using that method in control samples and aquaria over the last year or so. And in the last 6 months or so, we've been conducting field trials, both in England but also in Ireland, with different fisheries island. And that's been going really well. We've got some really positive results on that. And the guys involved in taking those samples were also flight netting. And so we found that actually the samples, eDNA samples, compared really well to the flight netting, and in some cases actually found eels in locations where they knew there were eels, but they didn't have
We have we wanted to determine for our project population connectivity of common species of eel in different countries like Indonesia, Philippines, and Myanmar. And I think what he's asking is it possible for eDNA to give us an indication if for example, the Anguilla marmorata in the Philippines and the Anguilla marmorata in Indonesia, physical sample of the eel from the different countries.
Yeah, so that's a really good question, and that's something thank you. So it's a really good question, and that's something that we are going at circular RNA. And if we can extract that from environmental samples, that would start to give us a lot of information, not only about the sex and life stage, etc., of the eel, but also potentially its place of origin. One of the problems that we have at the moment that we're trying to overcome is that the pieces of environmental DNA that you find within the eel are very short fragments in comparison to the DNA that you would get from taking a sample directly from the eel itself. Because they've been exposed to environmental conditions like UV radiation and changes in temperature and pH, and also microbial action, the fragments that you find are a lot shorter, and so they actually give us a lot less information than we would like to see. So one of the things that we're working on is trying to develop assays which could perhaps give us that information in a different way. I hope that answers your question.
Estimate, a stock assessment estimate of the different species in the different areas.
So you would be able to estimate your stock. It wouldn't give you a number, but it would tell you that you had eels present, and then that would allow you to perhaps go in with another survey method to look at population abundance. So it's really a quick and easy way to tell if you have eels there to begin with, using less time and labour costs, and perhaps if you had to go out and fight.
My question is, how this methodology eDNA effectivity in the high disturbance area, because we know in Southeast Asia the record system are using for the transportation, and there are a lot of waste from the housing, the industry and agriculture. And my question is, can be the eDNA methodology effective in the high disturbance area?
I don't know if you got that, Stephanie. Just some of the rivers here have got a lot of waste in them, or runoff from terrestrial farming or other,
We're doing some experiments on that at the moment. Changes in pH have been shown to degrade the DNA very quickly. So things like that might lose the DNA in the environment. If you have eels present, you should still be able to pick them up. You need to be aware of the water quality so that you can determine if that may impact your results. So we would always DNA.
Okay, so now